So hello to whoever is watching this. So today I would like to discuss about physics. I don't know what really physics is. I mean, of course I'm not doing masters in this subject, but still I really don't know what physics is. Uh, to the most in the most basic way, if I say what is, I would say uh, understanding nature. Understanding nature. So basically, uh, the most typical example, if I have a ball, I throw it up. Eventually, this ball just comes down. Uh, so many things happening, like so many childish questions. Like if you have, like you see stars in night, provided you have a clear sky, and you might ask, why don't they come down? Why does the moon doesn't fall on Earth? Questions like this, physics answers this. Physics just answers this. So many questions. We just made a structure. Human beings made a structure to understand the world around us. That structure is physics, and so many questions. Like I don't know where to start, where to end. Physics is really a very wide, vast subject. Uh, it has no ends. Maybe it does, but we don't know. What will it be? So many weird ideas come from physics. Like for example, in in your day-to-day life, you know that whatever is moving, if it is moving in some direction, given enough time, it moves, but it just stops. Whatever it is, let's say you have a floor, you have a ball, you just give it push, and it rolls and rolls and rolls and rolls and rolls, but eventually it just comes to a stop. You have a ball, you throw it up, it won't keep going up. Eventually it just stops and comes down and bounces, stops. So for a common person in his everyday life, I don't think he has seen anything at all which will just keep going. Whatever it is stops. Whatever it is, it just stops. But this is where physics come. It says no, 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 nothing will stop on its own. Physics says the opposite. If something keeps going, it will keep going. It will only stop if something else makes it stop. This is very opposite to what we have seen and observed. uh, but I think we never, maybe we never looked closely around, or it is the way it is. So basically, when you have a ball and you just pushed it, though it appears that it's stopping on its own, it is not stopping on its own. When you zoom out, this floor has this tiny teeth, like friction. This is not a perfectly smooth floor. It has these ups and downs, and every time this ball moves, it comes across these ups and downs. And what happens is, it gets slowed down because of this bumps, and this ball just eventually stops because of this tiny bumps. So provided you had no bumps and it was perfectly smooth, I mean, simply speaking, you are never supposed to stop. The ball is never supposed to stop. Same thing applies in many other aspects, even this ball. So basically what physics says is, if if you have this ball and you just throw it up, though it looks it's just stopping on its own and coming down, no, it's not stopping on its own. There is this thing called gravity which just constantly pulls everything down. So as it's going up, gravity at every instant it pulling it down, 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 and it just keeps pulling it down. So basically physics is the exact opposite. Nothing can stop on its own, nothing will stop while it's traveling. It will only stop when something else, I don't know what that something else is, it depends. It can be anything, but that something will make it stop. Or yeah, that something must only that something can make it stop or make it slow down. If there is not that something, it should technically keep going. Physics has a lot of answers. Like when you look at the sky, you see the moon. I hope you can see the moon. And you may ask yourself, why does this not fall on us? Why is just staying there on the sky? Does this mean God exists? Is it just letting it be there so that humans can live until he gets mad and this just falls on the sky? I mean, falls from the sky? Maybe, but what physics says is this moon is actually rotating, revolving around your uh, your Earth. So basically, Earth is round. So Earth is round. This is your Earth. This is your Earth, and this moon is revolving around your Earth. Well, for someone like you, it might appear that wait, it's not moving at all, but it's moving. It's just that you are not able to see it. You can't see it, but it's moving. You have to come outside of Earth. You have to go outside Earth and see. If you see from somewhere here, you will able to see that it's moving. Also, whether something is moving or not depends on how you are seeing it. If you see it in a certain way, it's not moving. If you see it in some way, it's moving. That's also a thing. So uh, so what physics says is, imagine, so basically there is gravity. Okay, physics itself says there is gravity, so moon is supposed to fall down. But what is happening is, when this is about to fall here, the moon is revolving, right? um, while it's at an instant, if it's about to fall here, it just goes here, and then again gravity has come down, it's like no, it comes again here, and it just keeps doing it. It just keeps escaping gravity because of its rotation. So basically rotation creates a kind of force of its own. uh, we uh, there are there are words called centripetal, centrifugal, things like that, which don't matter. Basically rotation, revolving, creates a force of its own, which makes stops things from falling. This is the reason why we don't just fall towards the sun either. Like sun is there, there is gravity. If moon should fall, then our earth should also fall towards the sun, but it doesn't, because our earth is also revolving. Every instant sun tries to pull it down, but the earth is like no, I will not. At this instant, if the earth sun tries to pull it here, it comes here and just happens this. Again it's here. The earth keeps escaping the sun's gravity because of its rotation. We have a word called angular momentum for this. Because of its angular momentum, it just never falls. So yeah, this is what physics says, why the moon doesn't fall on earth or vice versa. And we also have other terms, like for example, let's try asking some other question, like what can we ask? uh, Well, I don't know. I'm not a kid anymore. When I was kid, I used to have a lot of questions, and but now everything just feels dead. No questions. A lot of answers, but answers feel meaningless. But we do. But these answers are incomplete answers. Every time you have an answer, with that answer comes a question as well. Most of the time, at least. So yeah, at least this is very nice. But physics is also not perfect. Like when you have like uh, as time passes, physics keeps getting better and better. More people work, more people give better ideas. But when you have extreme cases, physics doesn't work. It will work eventually, maybe in the future, but right now we just don't have much um, ideas. Like for example, if what happens when the sun becomes way 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 bigger than it already is. uh, well, other than it eating our earth up. Imagine a sun so strong, so strong that it has a pulling power, gravitation pulling power, millions of times, millions, billions of times stronger than our own sun. Well, that thing we call it a black hole. Nothing escapes from a black hole. It just sucks up everything, everything. There is something called around this thing called black hole. There is a boundary called an event horizon. If you are close to it, if you are around here, nothing can save you. Nothing. You will go down. Nothing can save you. You can never escape the event horizon. So the problem is physics severely gets broken down when you pass a certain point, so somewhere inside this horizon, somewhere here. We call this region the singularity. We don't know what happens around black hole in this region. Physics just fails there. We don't have any ideas. Physics doesn't even work. uh, well, so this is for a big, this is when something becomes too big. Physics also doesn't work when something is very small. We, in fact, we don't have any physics at all which perfectly describes things small. It For the things which are small, physics can only give probability. Okay, that's a big word. Chances, likelihood. So basically what I'm saying is, let me take an example. Let's say you have a ball, a medium size ball, whatever size ball you are imagining, let it be that way. A ball which can at least fit in your hand. Imagine I make this ball shrink. I get a smaller ball, and also it's smaller in size, and also it's less heavy. I mean, I just everything made hundreds times smaller. Well, it's not a big deal. I mean, you can still, it's still a ball, right? Now imagine I make it even smaller. I keep making it smaller and smaller and smaller. Well, the problem is you will still, it doesn't matter how small it is, right? It should still be a ball and it should behave like a ball. But the problem is physics says no. If you keep making it smaller and smaller and smaller and smaller, at somehow if it becomes very 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 small, it is, even though you shrink this ball, like it was a ball and you're just changing the size, not the shape. Its shape is completely gone. There is no such thing as a ball anymore if you made it very very small. You This is not a ball anymore. This is this is something very very weird, very hard to even explain. Now the problem is when you make something very small, very 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 small, whatever it is, if it's very very small, its weight, mass, everything going down. then the physics we know for the big world cannot explain it. What I mean is, this ball you can see, let, very small. Imagine this ball, I made it like millions of times smaller. Then this ball is not a ball anymore. It's kind of like a, some people say it it behaves like a wave. This ball is a something like a, how should I say, a tiny wiggle. Water waves, like we have water, yeah, waves, not exactly like that, but what I'm trying to say is, this ball cannot bounce the same way you imagine bouncing. Like, imagine I have a wall here, and imagine I become very small as well, and I somehow managed to push this ball, kick this ball. If I manage to kick this ball here, so what should a normal ball do? A normal ball will just bounce back for this wall. This is a very solid wall. But the problem is, if this is very small, very very small, if something is very very small, we say it is quantum size. Uh, we don't say quantum size, but it's quantum scale, whatever it is. So the problem is, if something is very small, if you manage to throw it, kick it in this direction, we no longer know what happens. We did some, what do we say, experiments. We did some testings, and we found that sometimes this ball falls, and sometimes magically it just passes through this wall if things are very small. So basically, if things are very small, weird stuff happens. If things are very 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 big, again weird stuff happens. And if things are medium size, for medium size we have a good I will not say good grip. Even in medium size, everything breaks down. Many times things break down. Like, for example, there is something. If imagine you have a sun. Imagine you have sun and earth. So earth revolves around sun. Nice, right? Perfect. But the problem is, even if I add one extra, let's say some asteroid here, a big asteroid, big chunk of asteroid, and I'm asking you, what will happen? Will this crash with the earth or not? The thing is, it becomes very very hard. Just adding one extra body, it becomes very hard to calculate. Now imagine two extra bodies, three extra bodies. You may ask, well, it's hard to calculate, but you still have a way, right? You have strong enough computer, you should still be able to calculate. Well, you should be able to calculate. Yes, I think yes you can, but maybe there is no computer like that at all which will be able to do such complicated calculations. If the problem just becomes that hard, we just don't have any simple way. If you have two bodies, just two bodies, earth and sun, it works well. Three bodies, it's very difficult. Four bodies, it becomes even difficult. So something which we claim that we know everything of, even there, just increase a little changes, just add a little changes, and everything just appears extremely difficult. Okay, so this is everything I said so far was a very layman's, uh, a very very, I think, childish, not even childish, a very stupid, should I say, I don't know, a kind of rubbish, uh, talking of physics. Physics is hard. Really, physics is hard. Physics, you may say it's easy, but what physics is easy? What do you mean physics is easy? There are so many different physics. There is quantum physics. There is this low, very small size physics. You have medium size physics, which we call classical mechanics. Small size physics, medium size physics. You have very big size physics, which we call cosmology. Which physics do you mean? Do you even know what you're talking about? Physics is, when you say physics is, what do you really mean? It's easy to explain, it's easy to do that, easy to do this. Well, nothing is easy at all. You can't explain anything perfectly. You can just have boundaries. Under these boundaries, you can claim, yeah, under you can just make boundaries and you can say under these boundaries everything is perfect. Yeah, you may just celebrate that under these boundaries everything is perfect, but maybe not, maybe you're not sure there as well. Maybe there are tiny loopholes which you are not able to explain. There is no idea so far which explains everything. There is no idea which says that which just encloses everything and says, yeah, we are done. Anything you ask me, I can answer it using that one idea. There is no such thing like that. There are just domains, there are different realms and worlds. They have different worlds. Each world has its own rules. Okay, each world has its own rules. And the thing is, you can, if you make severe changes in one world, you just go to the other world. But there is no there is no idea which just puts them all in one world. There is nothing like that. Nothing is perfect at all. And you may, if you have decided that you wanna study this subject, you may enjoy it in some instances, and you may also reconsider your life choices. You may do a lot of stuff, but once you have started and you have invested enough, remember that there is there is always going back, but when you are going back, reconsider why you even started. So this is a little what should I say, layman's this is a little, what should I say, physics explained, not even explained, like a talk of physics, a subject made by creatures who were once monkeys from cracking stones to make fire, to uh, blowing up cities, killing billions of other monkeys, billions of other babies, children, women, men, indiscriminately, just being capable of wiping everything up. This is where, this is how far we have came. This is what monkeys are capable of. Tailless monkeys. So yeah, that's it. I think, I hope I can talk about the literature of physics in next videos, if I make. This is just a discussion not even discussion. This is just a rubbish talk of physics. What physics? What physics may be. And if you uh, think you're an expert in this, good for you. Hope you are able to sleep well at night. Uh, yeah, nothing more than that. Uh, Whoever is watching this, you tortured yourself for almost half an hour. You went through all these about 26 minutes. I won't thank you, but yeah, I hope good things happen to you. So, bye.